Subunit, both.
A subunit, yes, and also their adjuvant system is different. They are using LM with CPG. Their data also, I didn't see, looked at very critically on that, but looking at hamster data, you know, in our case, we got our animals sterile almost, we got almost 1 log, below to 1 log at the age of 14, whereas in the control, you have 6 logs. So that's the benchmark we have taken and compared with the others. And I think they have, they are in between 1, 2, you know, somewhere there. I don't want to comment on that, but
it's
yes.
Okay, so anyway, congrats, and the seminar is open for any further questions. Yeah, please.
Thank you so much, Ravi. I really enjoyed your presentation.
Thank you.
And I'm sure you have carried a wonderful technology from your postdoctoral experience. So my question was, today we are thinking about inhalation vaccines. So have you thought about that? Converting this subunit protein vaccine, will that work in the inhalation route?
Yeah, that's a very important question. Indeed, we have done that. So we tried intranasal immunization, but the adjuvant which we are using, I cannot name that because it's, you know, as I said, there's an unpublished thing. We get good antibody response, but neutralization is inferior than what we are getting intramuscular. So what we believe that if we are right vehicle adjuvant, there is no reason that why we cannot use this protein in the intranasal route and inhalation vaccine. So that is one of the future investigation which we would like to do. And we are also looking for the collaborator who can help us in that adjuvant side, the delivery system side. So we can make the molecule any molecule, but that side we need. So we are looking for collaborator who can help us in getting the right things which we can be used to deliver through intranasal routes.
Thank you for the presentation, sir. It was very nice to see. I have one basic doubt. So you've identified 3 target proteins in Staphylococcus aureus, but are they present in other bacteria as well? Like how do you make it specific to Staphylococcus aureus?
It's very important. So, and that is one of the criteria also we use when we design the antigen, that if anything, you know, present in the commensal bacteria, generally that is discouraged. But so far, these antigens are specific to Staph aureus. Like alpha hemolysin is Staph aureus specific, that all the 4 antigens, they are very specific to Staphylococcus. Even epidermidis, we don't see a couple of them.
Sir, do you add the parameters for refining at the beginning?
Yeah.
Okay. Sir, one more question I have, a general question. Why is it a disadvantage if the antigen is a housekeeping gene? Mm-hmm. Like, even if it is surface protein, why is it a disadvantage if it's a housekeeping gene?
You know, housekeeping gene, if you are, first thing is that the localization. If it is localized on, inside the cell, you know, that will be difficult to be accessed by the immune system. If it is, let's say, it's any housekeeping gene, that may create issue in the autoimmunity, or antibody against that housekeeping gene may create another problem. So that is why you cannot interfere the housekeeping function. You know, if you immunize with those protein, the antibody will be generated, and that may target the housekeeping gene, which may reflect in some other problem.
So the housekeeping gene of that bacteria or other bacteria as well?
That bacteria, like housekeeping gene of the Staph aureus, maybe mostly they are conserved across the bacterial. So it may be similar to the commensal bacteria also,
Okay. Thank you, sir.
which are otherwise beneficial.
Thank you, sir, for the presentation. I have a very small query. So, you use in silico method. Did you apply the rationale also for generating more potential vaccine rather than trying for the all?
You know, at that point of time when we are screening, you cannot, you can just look for the signature of protein, whether it can be exposed on the surface. Like for the gram-positive Staph aureus, we look for LPXTG motif, which anchored the surface protein. So the protein having the LPXTG motif potentially could be exposed on surface. Similarly, if it has a secreted signal, it may be a secreted protein. So at that point of time, you just look for these few filters that whether it is exposed on the surface, can be exposed on the surface, or it is secreted.
Thank you, sir.
So, thank you. I think no more questions.
Thank
Yeah,
you,
yeah.
sir.
Please.
Sorry. I have some basic question. Like in SARS-CoV-2, it has seen that it has been mutated into different variants. So, how this vaccine is effective in a different variants? Is it same or it will vary?
Yeah, this I could not explain. The variants basically, there is no variant where vaccine is not effective completely. What variant did that the protective titer has been increased. For example, to protect the wild type strain, you need, let's say, 1 microgram of antibody per ml. In the variant Delta Omicron, it has increased couple of fold.
So we have.
Protection is there.
Yes.
So protective titer, what all the data says that protective titer for those vaccines actually increased in this vaccine. Protection is there because vaccine works in a very different way. It targets multiple, different ways. There polymer antibody is targeted in different way and the cellular immunity and all.
So we need a large dose of vaccine.
No, generally vaccine are very different thing. You need very small dose. It's not like monoclonal antibodies. Like anti-cancer antibodies you require in mg. Here you require in 5 microgram, 10 microgram. So it's quite a small dose because that particular antigen is not going to work. The response generated against that antigen is going to work in the body.
Okay. So you have used a spike protein.
Yeah.
So major mutations will occur in spike protein. So whatever antibodies are getting produced in body, so they will affect us in a similar way, or will it recognize that variant or not? So.
It is recognized variant that the problem may be more relevant in the case of monoclonal antibodies.
So we can
So when
continue
we are-
the discussion in the
Yeah,
panel discussion.
We can have offline discussion also because
Yeah.
now time is.
So thank you.
Yeah.
Thank you, Dr. Ravi, for giving this wonderful lectures and developing this platform technology. And now, on behalf of the organizing committee, I invite you to receive the memento.
Thank you. Thank you.